Hello everyone, this is Brangans Overbroad and welcome to a new video. Today we're going to be talking about everything you need to know about Venus. And yes, this is my second video, so editing is still probably going to be really bad. So, Venus, the second planet from the Sun, is named for the Roman goddess of love and beauty. The planet, the only planet named after a female, may have been named for the most beautiful deity of her pantheon because it shone the brightest of the 5 planets known to ancient astronomers. In ancient times, Venus was often thought to be 2 different stars, the evening star and the morning star. That is, the ones that first appeared at sunset and sunrise. In Latin, they were respectively known as Vesper and Lucifer. In Christian times, Lucifer, or Lightbringer, became known as the name of Satan before his fall. However, further observations of Venus in the space age show a very hellish environment. This makes Venus a very difficult place to observe from up close because spacecraft do not survive long on its surface. For physical characteristics, Venus and Earth are often called twins because they are very similar in size, mass, density, composition, and gravity. However, the similarities end there. Venus is the hottest planet in the solar system. Although Venus is not the planet closest to the Sun, as that title belongs to Mercury, in our previous video, its dense atmosphere traps heat in a runaway version of the greenhouse effect that warms Earth. As a result, temperatures on Venus reach 870 degrees Fahrenheit, or 465 degrees Celsius. More than hot enough to melt lead. Probes that scientists have launched there have survived only a few hours before being destroyed. Venus has a hellish atmosphere as well, consisting mainly of carbon dioxide with clouds of sulfuric acid, and scientists have only detected trace amounts of water in the atmosphere. The atmosphere is heavier than that of any other planet, leading to a surface pressure 90 times that of Earth. Incredibly, however, early in Venus's history, the planet may have been habitable. According to models from the NASA researchers at the Goddard Institute for Space Studies, the surface of Venus is extremely dry. During its evolution, ultraviolet rays from the sun evaporated water quickly, leaving it in a prolonged molten state. There is no liquid water on its surface today because the scorching heat created by its ozone-filled atmosphere would cause any to boil away. Roughly 2/3 of the Venus surface is covered by flat, smooth plains that are created by thousands of volcanoes, some of which are still active to today, ranging from about 0.5 to 150 miles, or 0.8 to 240 kilometers wide, with lava flows carving long-winded canals up to more than 3,000 miles or 5,000 kilometers in length, longer than on any other planet. 6 mountainous regions make up about 1/3 of the Venus surface. One mountain range, called Maxwell, is about 540 miles, or 870 kilometers long, and reaches up to some 7 miles or 11.3 kilometers high, making it the highest feature on the planet. Venus also possesses a number of surface features unlike anything on Earth. For example, Venus has a corona, or crowns, ring-like structures that range from roughly 95 to 360 miles, or 155 to 580 kilometers wide. Scientists believe these formed when hot material beneath the crust rises up, warping the planet's surface. Venus also has tesserae, or tiles, raised areas in which many ridges and valleys have formed in different directions. While conditions on Venus that could be described as infernal, the ancient name for Venus, Lucifer, seems to fit. However, this name did not carry any fiendish conditions. Lucifer means light bringer, and when Seen from Earth, Venus is brighter than any other planet or even any star in the night sky because of its highly reflective clouds and its closeness to our planet. Venus takes 243 Earth days to rotate on its axis, by far the slowest of any of the major planets. And because of this sluggish spin, its metal core cannot generate a magnetic field similar to Earth's. For orbital characteristics, if viewed from above, Venus rotates on its axis the opposite way that most planets rotate. This means on Venus, the sun would appear to rise in the west and set in the east. On Earth, the sun appears to rise in the east and set in the west. In the Vesan year, the time it takes to orbit the sun is about 225 Earth days long. Normally, that would mean that days on Venus would be longer than years. However, because of Venus's curious retrograde rotation, the time from one sunrise to the next is only about 117 Earth days long. On the transit, and here is the picture of a transit of Venus on June 5th, 2012, when the planet transited in front of the sun for the last time until the year 2117. And here's some of the Venus parameters according to NASA. For orbit and rotation, the average distance from the sun is 67,237,910 miles, or 108,208,930 kilometers. By comparison, that's 0.723 AU. And the perihelion, which is the closest approach to the sun, is 66,782,000 miles, or 107,476,000 kilometers. By comparison, that's 0.73 AU. And the aphelion, which is the farthest distance from the sun, is 67,693,000 miles, or 108,942,000 kilometers. And that's 0.716 that of Earth, or 0.176 AU. And right here you could see Venus's southern hemisphere as seen in ultraviolet light. And by composition and structure, the atmospheric composition by volume is 96.5% carbon dioxide, 3.5% nitrogen, with minor amounts of sulfur dioxide, argon, water, carbon monoxide, helium, and neon. The magnetic field is only 0.000015. The magnetic field is only 0.000015 times the strength of Earth's magnetic field. For the internal structure, Venus's metallic core is roughly 2,400 miles, or 6,000 kilometers wide. Venus's molten rocky mantle is roughly 1,200 miles, or 3,000 kilometers thick. Venus's crust is mostly basalt, and is estimated to be 6 to 12 miles, or 10 to 20 kilometers thick on average. For climate, the very top layer of Venus's clouds zip around the planet every 4 Earth days, propelled by hurricane-forced winds, traveling roughly 224 miles per hour, or 360 kilometers per hour. This super rotation of the planet's atmosphere, some 60 times faster than Venus itself rotates, may be one of Venus's biggest mysteries. The winds at the planet's surface are much slower, estimated to be just a few miles per hour. The Venus Express spacecraft, a European Space Agency mission that operated between 2005 and 2014, intriguingly found evidence of lightning on the planet. This lightning is unique from what that was found on other planets in the solar system, in that it is not associated with water clouds. Instead, on Venus, the lightning is associated with clouds of sulfuric acid. Scientists are excited by these electrical discharges because they could break molecules into fragments that could then combine with other fragments in unexpected ways. A long-lived cyclone on Venus, first observed in 2006, was observed in constant flux, with elements constantly breaking apart and reforming. The clouds also carry signs of meteorological events known as gravity waves, caused when winds blow over geological features, causing rises and falls in the layers of air. Unusual stripes in the upper clouds of Venus are dubbed blue absorbers, or ultraviolet absorbers, because they strongly absorb light in the blue and ultraviolet wavelengths. And these are soaking up a huge amount of energy, nearly half of the total solar energy the planet absorbs. As such, they seem to play a major role in keeping Venus as hellish as it is. Their exact composition remains uncertain, but some scientists suggest it could even be life, although many things would need to be ruled out before accepting that conclusion. For research and exploration, the United States, Soviet Union, European Space Agency, and Japanese Aerospace Exploration Agency have developed many spacecraft to Venus, more than 20 in all so far. NASA's Mariner 2 came within 21,600 miles, or 34,760 kilometers of Venus in 1962, making it the first planet to be observed by a passing spacecraft. The Soviet Union's Venera 7 was the first spacecraft to land on another planet, and Venera 9 returned the first photographs of the Venusian surface. The first Venusian orbiter, NASA's Magellan, generated maps of 98% of the planet's surface using radar, showing details of features as small as 330 feet or 100 meters across. The European Space Agency's Venus Express spent 8 years in orbit around Venus with a large variety of instruments, and has confirmed the presence of lightning there. In August 2014, as the satellite began wrapping up its mission, controllers engaged in a month-long maneuver that plunged it into the outer layers of the planet's atmosphere. Venus Express survived the daring journey, then moved into a higher orbit, where it will spend several months until it runs out of fuel. By December 2014, controllers expect to send the craft plunging to its death through the planet's atmosphere. Japan's Akatsuki launched to Venus in 2010, but its main engine died during a pivotal orbit insertion burn, sending the craft hurtling into space. Using smaller thrusters, the Japanese team successfully performed a burn to correct the spacecraft's course. A subsequent burn in November 2015 successfully put Akatsuki, I slaughtered that pronunciation, into orbit around the planet in 2017, having successfully achieved a modified science orbit around Venus. Akatsuki spotted another huge gravity wave in Venus's atmosphere. As of at least March 2017, NASA and the Russian Academy of Sciences Space Research Institute have discussions about collaborating on the Venera D mission, which would include an orbiter, a lander, and perhaps a solar-powered airship. The mission will launch sometime in the 2020s. In recent years, NASA has funded several extremely early-stage mission concepts that could look at Venus in the coming decades. Under the NASA Innovative Advanced Concepts program, although their success is not guaranteed, this includes a steampunk rover that would use old-school levers instead of electronics, which would fry in Venus's atmosphere, and a balloon that would check out Venus for low altitudes. Separately, some NASA researchers have been investigating the possibility of using airships to explore the more temperate regions of Venus's atmosphere. And like I said before in the previous video, we have several audio clips of showing the planets, what they actually sound like, as recording radio waves and other electromagnetic waves and converting them into sound waves. Here's that video now. So, I've got everything, guys. So that's pretty much it for today's video. I'll see you all in 3 days. Let me think, which will be Monday, with the next video, which will be everything you need to know about Earth. And sorry if I'm stuttering a lot, because I'm reading this off of some text that I typed down, and I have a cold right now. So see y'all in the next video. Bye.